Recording in progress.
What was the last point? Hmm?
Example 19.
Example 19. Okay, so in this example, we learned that if you move ahead in the distance, phase will decrease. But if you move ahead in the time, phase will actually increase. So two phase differences are to be added to get the total phase difference, right? Delta phi 1 and delta phi 2. We actually had to add. Solve this.
The question completely.
Hmm. So calculate wavelength. What is the answer? What is the answer?
And right equals to 2 pi a small b.
Bar. Any other? We have amplitude A, wavelength lambda. Capital V is what? Wave velocity. And small v is maximum particle velocity. So what we can do? We know maximum particle velocity is equal to what? It
omega.
is a omega. And wave velocity is what? Coefficient of time upon coefficient of x, omega upon k. What you can do? You can divide these two to eliminate omega. You can divide these two and you can get Vp max upon V wave is equal to AK. Now K is what? 2 pi by lambda. Vp max is capital V. No, Vp max is small v and V wave is capital V. So lambda is equal to 2 pi capital V by small v into A. Done. Have you got this answer? You could have simply taken ratio to relate the given parameters. You have to find answer of wavelength in terms of given parameters. Given parameters are amplitude, capital V and small v. Solve this. Snapshot, photograph at given time. Snapshot means photograph. So at a given instance of time, we have been given the photograph of the string. Means particles at different locations x have different positions y, like this. And the wave is traveling in the rightward direction. So this is the photograph at given time instance. After some time, what will happen? The wave will move right. Yes or no? The same shape, you will observe that it has moved somewhat rightwards. Means it will be like this after some time. Yes or no? Initially it is white, now it is yellow. Means all the particles which were present on the white line will come on the yellow line. Means these people will actually move down. These people will actually move up. These people will actually move up. Actually, particles are not moving forward. These people will move down. चेक करा काय काय होईल. So now you can say that these people will come down, these people will go up, and you will have a feeling that the crest has traveled forward or the trough has traveled forward. Actually, particles are not moving forward or backward. Particles are moving up and down. But you will have a feeling, yes or no? We have seen the animation. In that animation, the particle was performing only up down motion, but you had a feeling that it was moving forward or wave is moving forward. What is actually moving forward? Energy and momentum is being moved forward. So tell me, which of the particles have particle A, B, this top point is C, this point is D, this is E, this one is F, this bottom point is G, this is H, and this is I. So which points have upward velocity? What is the answer? Which points have upward velocity? Hmm?
D, E, F.
A. A is at the mean position, and at the next moment it will move down. B is somewhere middle, and at the next moment it will move down. C is at the extreme. At the next moment it will move down, but C is right now not moving because it is at extreme. So C is at rest. So A is at mean and moving down. B is also moving down. At that instance, it is at not extreme. So it is moving down. C is at extreme. So C is actually at rest. After some time, it will move down. But C is right now at rest. D is not at extreme. So it is definitely moving up. After some time also, it will be seen to be moving up. E is at mean. So it is moving up. F is also moving up. G is at extreme. So G is actually not moving. It may seem that this arrow is up means G is moving up. No, after some time it will move up. Right now it is at extreme, so it is at rest. Right now it is at extreme, so it is at rest. What about H? H is actually moving down. It is not extreme, somewhere middle, and it is going towards extreme. So it is moving down. What about I? I is at mean and it is moving down. Clear? Particles on the white line will transfer themselves to the yellow line after some time, and you will have a feeling that wave has moved forward. Yes sir. Now which points have upward velocity? What is the answer of upward velocity? D, E, F. You can check what is their answer. What is their answer? D, E, F. The points moving downward, A, B, H, I. Points moving downward are A, B, H, I. Yes, A, B, H, I. Which points have zero velocity? C and G. C and G. Which points have maximum magnitude of velocity? Maximum magnitude of velocity means people at mean. Which people are at mean? A, E, I. A, E, I are at mean. Yes or no? So they will have maximum magnitude of velocity. You can check their answer. A, E, I. Clear? Next. Velocity of a transverse wave on the string. Let us try to understand this. Velocity of a transverse wave on a string. So we are talking particularly about transverse wave and on the string. What is the formula? V is equal to under root T upon mu. What is T? Tension in the string. What is mu? Mass per unit length of the string. Now this formula we are going to accept. T is what? Tension in the string. T is what? Tension in the string. Mu is what? Mass per unit length. Of course, this can be derived. This is what? Mass per unit length of the string. It is clear that the velocity of the transverse wave propagating along the string depends only on the characteristics of the string. Yes, we know the frequency of the wave is decided by the source, but speed is decided by the medium. Speed is decided by what? Medium. Frequency is decided by the source of the wave, but speed of the wave is generally decided by the medium. So it depends on the parameters T and M. They have said M, what it should be. Sometimes mass per unit length is also written as a small m. So they may have written here m. So let us change that to mu. Here they should have written mu. What is T? Tension in the string. What is mu or small m? Mass per unit length of the string. And that speed is independent of the frequency of propagating wave. Means all the frequencies will travel with the same speed. So string is a dispersive medium or non-dispersive medium. Speed is independent of frequency. Independent, non-dispersive. Dependent, dispersive. So all the waves of all the frequencies will move with the same speed on the string. And that speed is under root T by mu, where T is the tension in the string and mu is the mass per unit length of the string. Now, what is the second point? If the transverse mechanical wave, instead of propagating along the string, it propagates through the solid medium or solid media. Media, plural of the medium. For example, seismic wave. Seismic wave? Waves during the earthquake which travel in the rocks. The formula is under root eta upon rho. Eta is what? Modulus of rigidity. And rho is what? Density of the solid. So what is the formula for transverse waves? Transverse waves. For the string it is under root T by mu. And for solid medium it is under root eta upon rho. Eta is modulus of rigidity and rho is density. So we have to remember these two formulae for velocity of a transverse wave. Is that clear? Any doubt in this? That's it. Let's move ahead. Solve this. A harmonic wave with a wavelength of 20 centimeter amplitude 3 centimeter. Harmonic wave means all the particles will perform simple harmonic motion. The velocity of the wave 2 meter per second, travels on string to the left, so it is traveling in negative x-axis. The mass per unit length of the string mu is 0.25 gram per meter. What is the frequency and period of the wave motion? How much is the tension in the string? Okay, now for tension, what is the letter that we shall use? For time period, let us use the letter P. So here P is the period and T is the tension. Don't use T for both. What is the position function of the wave? That is wave function. Okay. How will you figure out frequency? We have speed and wavelength. We know speed is equal to frequency into wavelength. V is equal to f lambda, or V is equal to lambda upon capital T, distance traveled upon time taken. In one time period, wave travels a distance of lambda. When particle completes one oscillation, wave moves forward by a distance equal to lambda. So from that, frequency is equal to what? Speed upon wavelength. What is the speed? 2. What is the wavelength? 0.2. So what shall be the answer of frequency? 10 hertz. Then time period. Time period is what? Reciprocal of frequency. So it has to be 0.1 second. What is tension? How will you figure out tension? Which formula you will use to figure out tension in the string? Wave, transverse wave on the string. Which formula you will use?
G equals to under root T by mu.
V is equal to under root T upon mu. So squaring on both the sides, T is equal to V square mu. T is equal to what? V square mu. So V square is 4 and mu is 0.25, but it is in gram per meter. So gram has to be converted meter as it is. So what is this tension T? 1 into 10 raised to minus 3. So it is 10 raised to minus 3 Newton. Next, what is the position function of the wave? Y is equal to A sine omega t plus kx or minus kx?
Plus K.
Plus kx. Why?
Plus K. Negative x direction.
Wave is traveling in negative x direction. Plus alpha. So write all these parameters. What is amplitude? 3 centimeter. So y will be in centimeter. You are writing this amplitude in centimeter. So y will be automatically in centimeter. Sine. What is omega? 2 pi f. So f is 10. So 2 pi f is 20 pi into t. Plus kx. K is 2 pi by lambda. What is wavelength lambda? 20 centimeter means 0.2. So 2 pi upon 0.2 into x. Or what you can do, you can keep wavelength in centimeter. You can write this as 20. So observe this carefully. This 20 pi will be in the units of radian per second. This time will be in the units of second. This 2 pi by 20 will be a radian per centimeter, and now x has to be used in centimeter. And let us take this alpha equal to 0 because it was not mentioned. We will assume that particle at origin starts its oscillation from mean. Origin वाल्या particle चे oscillation mean position ला चालू झाले असं म्हणा. Any doubt in this? असंच काढले का बघा तुमचे आन्सर्स. Solve this.
Centimeter per second.
Hmm?
20 meter per second.
त्यांचं आन्सर तुमचं आन्सर मॅच होते का बघा. देअर आन्सर इज 20. Check whether you get 20 or not. So this is very simple situation. What is to be done to figure out the speed? What is your answer? 20. So V is equal to under root T by mu. What is the tension? What will be tension in this string? What is responsibility of the tension? To balance weight of the hanging portion. What is that? 20 kg into G upon mu. 500 gram per meter. Convert. Gram you have to convert. So 500 gram means 10 raised to minus 3 kilogram. So this will come out to 20 meter per second. Clear? Any doubt in this? Solve this.
D.
Hmm. Hello ka? Hmm? How will you solve this? Two strings A and B made up of same material. What is the meaning of same material? What is the meaning of same material? Same materialचं meaning काय? In this for this question, what is the meaning of same material? What will be same? Same material means what will be same? Which physical quantity will be same for these two?
Density.
Huh? Which density? Mu. Density. Mass density or linear density? Mass per unit length will be same or mass per unit volume will be same? Mass per
Mass
unit
per
volume
unit
will be same.
volume.
So its density of A equal to density of B. The radius of the string A is double the radius of the string B. Density of the radius A, sorry, radius of the string A is 2 times the radius of the string B. Transverse waves travel on A with the speed equal to VA with the speed equal to VB on B. Ratio VA by VB. Ratio VA upon VB is equal to question mark. So what is speed? V is equal to under root T by mu. Now mass per unit length is basically area into density. Yes or no? What is mass per unit length? Mass of the string upon length of the string. What is mass of the string? Density of the string into volume. Volume is what? Volume of the string means what? Cross sectional area of the string into what? Length of the string. Do you get this? The string will have some cross sectional area. It will have some length. So what is replacement of mass per unit length? It is area into density. See, this L gets cancelled. Mass is what? Density into volume. Volume is what? Area of cross section into length. Length cancel. So mass per unit length is what? Area into density. So what you can do? You can call this as equation 1, this as equation 2. You can use equation 2 in equation 1. What is speed of the transverse wave on the string? V is equal to under root T upon mu. So T is T. Mu, mass per unit length is what? Area into density. Here area of cross section is not given. Radius of cross section is given. So write down pi r square into rho. Correct? Now, the strings have been stretched by same tension. Strings are of same material and they have been stretched by same tension. So here tension is same. Density is also same. These people are same. So V is proportional to what? 1 upon R. So velocity on A upon velocity on B is equal to radius of B upon radius of A. What is B by A? B by A. 2 or 1 by 2? B by A will be 2. Not 2. 1 by 2. असंच केलं होतं का बघा. How will you replace mass per unit length? Area into density. Mass per unit length is area into density. So what will be same? Density means which density? Material same means what same? Not mass per unit length same. Material same means what? I can take iron wire made up of iron and wire made up of iron. Both of them are iron. So what will be same? Density will be same. This is actually thicker wire. So it will have more mass in the same length. So when they say material same, it will be mass per unit volume same. Rho will be same. Mu will not be same. Mass per unit length, mu is area into density. Solve this. Then a string of length equal to 2x is stretched by 0.1x. So we have a string having length is equal to 2x. It's been stretched. When you stretch it, obviously tension will be developed in it. So use concept of stress and strain. There will be development of stress. From the stress, you can figure out what is the tension. And in that case, the speed of the wave was v. Now when it is stretched by distance is equal to 0.4x. So this was the elongation in the first case. This is the elongation in the second case. What is the wave velocity? Clear? So can I say Young's modulus y is equal to what? Stress upon strain. So stress is equal to what? Y into strain. Stress in the wire is tension in the wire upon cross-sectional area of the wire. Stress, tension in the wire, tension that has been developed in the wire upon cross-sectional area. So that will be equal to Y into strain, and strain is equal to what? Change in length upon original length. Fine. So we have the tension now, that is area into Young's modulus into change in length upon original length. So from this equation 1, you can write speed of the wave, transverse wave, that is equal to under root T by mu. Now you can solve it.
तर म्यूची व्हॅल्यू पण चेंज होईल ना म्यूची व्हॅल्यू पण चेंज होणार ना लेंथ चेंज झाली त्यामुळे
म्यूची व्हॅल्यू का चेंज होईल 0.1x is 5% of 2, so it can be ignored. 0.1x or 0.4x can be ignored. So take mass of the string constant and length approximately constant. So take mu constant. Take this mu constant. So V will be proportional to root of T. Tension is area into Young's modulus into change in length upon original length. These parameters are also fixed. So velocity will be proportional to square root of change in length. That's it. Approximately mu will remain constant. In reality, it will not. You're right. In reality, it will not, because mass stays the same, but after elongation, length changes. But that change in length can be ignored because that is somewhere around 5 to 10% that can be ignored. Up to 5% you can ignore it. So our answer will be obviously approximate. What will be our answer in this case? V proportional to root of delta L. So V dash upon V is equal to delta L in second case upon delta L in first case. Delta L in second case is equal to what? 0.4x. And in the first case it was 0.1x. So it will be 2. So V dash is equal to what? 2. 2 means what? Root 4. So this is 4 point something. This is also 4 point something. So root 4, root 4. It means the approximation that we have applied here fails. Now what we have to consider is the variation in length. Means mu cannot be taken as constant, because in the second case mu is what? 0.4x, and 0.4x is 20% of 2x. Can you ignore 20% change in length? No. You can ignore change in length only up to 5%. So this approximation fails here. So let's try to find out answer by taking mu not constant. By taking variation of mu under consideration, let's try to write down v is equal to under root t by mu. So under root tension, we have area into Young's modulus into strain. Now mu is what? Mass of the wire upon length of the wire. Now length of the wire has to be written as L plus delta L. Right? This is what we have to do. Now these parameters we will take approximately constant. Even this mass. These parameters we will take constant. So what do we have? In the numerator we have this delta L. In the denominator we have 1 upon L plus delta L. You cannot ignore this L. It is in addition. Addition मध्ये या L ला constant नाही घेता येणार. So it is under root delta L into L plus delta L. So V dash upon V is equal to under root 0.4x in the bracket 2x plus 0.4x, and in the first case it was 0.1x, 2x plus 0.1x. So all the x will get cancelled. What is the answer? 4 into 6, what is that? 24. And not 24, it's 2.4 into 4. 2.4 into 4. What will be the answer? This ratio is 4. 2 plus 0.4 is 2.4. 2.4 into 4. That will be 9.6 upon. This is 2.1. 9.6 upon 2.1. Can you divide by 3? Yes, you can divide by 3. So what will be the answer? 96 by 21 divided by 3. This will be 32. Divide by 3, 7. Is the answer correct now? 32 by 7. Under root 32 by 7. So you have to consider the variation of mu also. Final length L plus delta L. You can ignore these people L, Y, A and M. But this L cannot be ignored because it is in addition with delta L. Solve this. 26. A long string having cross-sectional area of 0.8 millimeter square and density 12.5 gram per cm cube is subjected to the tension of 64 Newton along the x-axis. One end of the string is attached to the vibrator moving in the transverse direction. So here we have source which oscillates up and down, transverse perpendicular. And let us fix the other end with some tension applied to the string. At time equal to 0, the source is at maximum displacement. So here, source is at maximum displacement. Let us take this as origin. So at t equal to 0, particle at origin is at extreme position. So we will take alpha or initial phase of particle at origin as 90 degree, pi by 2 radian. The source is at maximum displacement, that is y equal to 1 centimeter. That maximum displacement of the source itself is 1 centimeter, means amplitude of the wave will be 1 centimeter. Find the speed of the wave on the string. What will be the answer? This data is immaterial. Source will not decide the speed of the wave. Source, parameters of source will not decide the speed of the wave. Speed of the wave will be solely decided by string itself, the medium itself. So it is under root T by mu. Now tension is given to you. Mass per unit length is what? Area into density. Tension is given. Area is given. Density is given. This area you can write 0.8 into 10 raised to minus 6. Gram means 10 raised to minus 3. Cm cube means 10 raised to minus 6. Minus 6 minus 3 plus 3. So 12.5 into 10 raised to 3 kg per meter cube. That's it. You can solve this on your own. असंच केलंय का? You have done the same. Next, do this.
First of
Done. कळलं का नाही? हार्ली बसू नका, पटकन कॅल्क्युलेट करा. A transverse wave described by the equation y is equal to a sin kx plus omega t. So I got the value of k. 1 meter inverse. Actually it is radian per meter. They have written per meter. Doesn't matter. Propagates on the straight string having linear mass density, that is linear mass density mu, mass per unit length, 1.2 into 10 raised to minus 4 kg per meter. Find tension in the string. So what is the formula for tension in the string? It will be v square mu. Yes or no? V is equal to under root t by mu. T is equal to v square mu. How will you find out v? Mu is given. You need v. It is omega upon k. Coefficient of time upon coefficient of distance. Coefficient of t upon coefficient of x. Bracket square into mu. Now you can put the values. Omega is 30 radian per second. K is 1 radian per meter. Coefficient of t upon coefficient of x. Mu is what? 1.2 into 10 raised to minus 4. Now you will get the answer 0.108. तुमचं तुम्हाला कॅल्क्युलेशन करून आन्सर काढता आलं पाहिजे. I won't be showing the calculations now. Solve this. Assume pulleys as massless and strings as massless. Take pulleys and strings as massless objects. What is the answer?
Under root 1 by 2.
Ignore the options. Tell me the numerical value. What is value of v1 by v2?
Under root 1 by 2.
Under root 5 by 2.
1 by 2.
3 by 5. माइक बंद आहे तुझा.
Under root 0.5. 1 by
Under
2.
root 0.5.
हाँ.
So under root 1 by 2. Under root 1 by 2. Both the strings shown in the figure are made of the same material. Okay, material same. Can you see two strings? This is one string. This is one string. And this one is the other string. So this AB is one string. And this CD is the other string. The wave speed of the transverse wave in the AB is V1 and in the CD is V2. Then what is the ratio? We can assume the tension here as T. This T will pull this C down, T up. Now here, because pulley is massless, net force has to be zero. Pulley may have acceleration, but it has zero mass. So net force on the pulley has to be zero. So this T downward means this T by 2 upward and this T by 2 upward. This is a single string, so it must have same tension. Here, this is what you have to do. This is a single string. So a single string will have same tension everywhere. So if I take this tension as T, it will pull this pulley down. So this tension has to be T by 2. This tension has to be T by 2 because pulley is weightless, massless. So its net force has to be zero. It may accelerate up and down, but net force on the pulley has to be zero. So this is FBD of the pulley. So in the section AB, tension is T by 2, and in the section CD, tension is T. So V1 by V2, V is equal to under root T by mu. So tension in the AB section upon mu upon tension in the CD section upon mu. No need to say mu1, mu2. They are made up of same material and they have same cross section. Can you see same material and same cross section? It's not only material, it's also the cross section. It's not only density, it also the area which decides mu. So mu is same right now. So it's simply tension in AB section upon tension in CD section. In AB it is T by 2. In CD it is 2. So it has to be under root 1 by 2. Solve this.
Centimeter
20 meter per second.
20.
Answer is minus 20 meter per second. A taut string means string having tension. Taut string having some tension. If there is no tension, velocity will be zero. Having tension equal to 100 Newton and linear mass density is equal to 0.25 kg per meter is used inside a cart to generate a wave pulse starting from the left hand as shown in the figure. What should be the velocity of the cart so that the pulse remains stationary with respect to ground? So velocity of pulse with respect to ground should be equal to 0. So for that, what should be the velocity of the cart? So velocity of pulse with respect to ground means what? What should be the velocity of cart is equal to question mark. We want velocity of pulse with respect to ground equal to 0. So what should be the velocity of cart with respect to ground? This is the question. What is the question? Velocity of pulse with respect to ground. What should be the velocity of the cart? What should be the velocity of the cart? We see. So that velocity of the pulse or the pulse remains stationary with respect to ground. We want this pulse with respect to ground to be stationary. So can I write velocity of pulse with respect to cart is equal to velocity of pulse with respect to ground minus velocity of cart with respect to ground? VPC is equal to VP minus VC, relative velocity. Now what is velocity of pulse with respect to car or cart? It is under root T by mu magnitude and it is moving rightward. So plus under root T by mu. On the string, what is the velocity on the string means with respect to string. On the string means with respect to string. But string is attached to cart. So with respect to cart. This under root T by mu is a velocity with respect to cart. What is the velocity of pulse with respect to ground we want? We want pulse with respect to ground to be at rest is equal to minus velocity of cart with respect to ground. What is this? So what should be the cart velocity with respect to ground? Velocity of cart with respect to ground has to be minus of 20. So ती पल्स जी आहे त्याचा स्ट्रिंग वरती स्पीड 20 पाहिजे पण हा सगळा जो ऑब्जेक्ट आहे हा मागं 20च्या स्पीडने गेला पाहिजे म्हणजे इफेक्टिव्हली पल्स इथंच राहील. नेक्स्ट सिच्युएशन अशी असणार पल्स पुढे गेलेली दिसणार पण कार्ट माग आलेली असेल. काय झालं कळलं का? Cart has moved back, pulse has moved forward, but the ground person will see the pulse at the same place. Yes or no? After some time, what will happen? The cart will move back, the pulse will move forward. Effectively, with respect to ground, pulse stays at the same place. कळलं का? So the correct answer of velocity was minus 20 meter per second, magnitude 20. So you can write inside the cart, pulse is moving rightward. So cart should move leftward. Inside the cart means with respect to cart. Inside the cart means with respect to cart. Pulse is moving rightward. So cart should move leftward. See, I did the analysis using vectors because they said velocity. Of course, in the options, if all four options are positive, we will select plus 20. But we should know that the cart should move backwards. If cart moves forward with 20 and pulse is also moving with 20, then with respect to ground, effectively pulse will move with 40. Velocity of man and velocity of river. This cart will act as a river. If river is helping the efforts, then effectively final velocity of man with respect to ground will be more. Efforts, velocity of man with respect to river. Velocity of pulse with respect to cart is effort. And if you help the efforts, obviously the addition will take place. You have to oppose the efforts. So effectively with respect to ground, pulse stays at the same place. Pulse will definitely travel on the string. You cannot stop the pulse from traveling on the string. स्ट्रिंग वरती तर ती मूव्ह होणार, त्याला थांबवता येत नाही. देयर इज नो वे टू स्टॉप द मोशन ऑफ पल्स ऑन द स्ट्रिंग. इट विल मूव्ह, नो प्रॉब्लम, नो mechanism is available to stop this pulse from moving on the string. So it will move on the string. So only option to make the pulse come back is to move the card back. So with respect to ground, pulse will stay at the same place. Solve this. अलग आन्सर तुमचा 0.47 second. One end of the 12-meter long rubber tube with a total mass of 0.9 kg. So you can see the rubber tube AB. We have this rubber tube having length is equal to 12 meter and mass of the rubber tube equal to 0.9 kg. Fastened to the fixed support. This is fixed support. It has been fixed at point A. A cord attached to the other end. Okay, to the other end of the rubber tube we have a cord. We have a string. The cord attached to the other end passes over the pulley and supports an object of mass equal to 5 kg. The tube is struck at the transverse blow. The tube is struck a transverse blow at one end. So here we produce the transverse wave at one end of the string, or maybe here, doesn't matter. Find the time required for the pulse to reach the other end. So let's do the simple analysis and check whether we get the correct answer or not. Now, here we have data of rubber tube. So what is mass per unit length of the rubber tube? It is mass of the rubber tube upon length of the rubber tube. So it will be 0.3 upon 4 kg per meter. Now, what is tension in this rubber tube? Tension in the cord. What is tension in the cord? The weight of this block. So tension in the rubber tube can be taken as tension in the cord. What is tension in the cord? It's 5 kg into G. So it will be what? 50 Newton. Tension in the cord has to support the weight. Same tension will be transferred to this rubber tube. So it will be 50 Newton. G can be taken as 9.8. So take G as 9.8. So if it is numerical, take G as 9.8 because they have mentioned it. So 49 Newton. So what is time required to travel a distance of AB? So it is distance AB upon speed AB. So distance is how much? Length AB, length of the rubber tube. Speed is under root tension in the AB section upon mass per unit length of the AB section. Length of the AB section is how much? 12 meter upon under root T by mu. Tension here is 49 and mu is 0.3 upon 4. So 49 into 4 is 196. Outside square root it will be 14. And this 1 by root 3 in the numerator it will be root 3 or root 0.3. Something like this. What is root of 0.3? You can multiply this by 100. So 12 into 30 into 10 raised to minus 2 upon 14. 12 by 14 is 6 by 7. 10 raised to minus 2 square root is 10 raised to minus 1. And now you will have root of 30. This is time required for motion A to B. Distance upon speed. What is root of 30? This is root 3 into root 10, or you can simply say root 30. Approximately, you can take 5.5. What is 5.5 square? It is 30.25. So it's 5.5. So do this calculation and tell me the answer. 5.5 into 6. So it will be 33 upon 7. So what is 33 by 7? 28. Then we have 5. 7 into 7, 49. So do we get this 0.47? You should have figured out tension in the rubber cord. Sorry, tension in the rubber tube. Tension in the rubber tube is tension in the cord. Tension in the cord is weight of the block. Then you can figure out speed of the wave in the rubber cord. Once you get speed, you can simply say distance or length of the rubber cord or length of the rubber tube upon speed in the rubber tube. Speed in the rubber tube is under root T by mu. Clear? So they have simply given questions. Any questions? Okay, only one question remains. Then we have energy calculations. You can see these complex equations. Energy calculation in the wave. How to calculate energy per unit length, per unit time, intensity of a wave, power of the wave. Then again questions. So we have many questions here. What happens to waves when they change their medium? Some energy of the wave is transmitted, some energy is reflected. Energy, reflection and transmission. When wave hits the boundary of the medium, some of the energy is transmitted, some of the energy is reflected. So you can calculate coefficient of transmission, reflection. We know when a wave is incident on the boundary, some part of it is absorbed, some part will be reflected, some will be transmitted. Here we assume absorption equal to 0, so only reflect and transmitted. Then we have standing waves. Let's not talk about standing waves. So this, up to this, we have one part of the chapter, means progressive waves, and after that we have नॉन प्रोग्रेसिव्ह और स्टँडिंग वेव्स. सो 2 चॅप्टरचा मिळून एक चॅप्टर बनवलाय त्यांनी. सो इट्स अ बिग चॅप्टर. इट्स अ बेसिकली युनिट. दोन्ही चॅप्टर्सचा मिळून एक चॅप्टर त्यांनी वेव्स म्हणून दिलाय. इट इज बेसिकली ट्रॅव्हलिंग वेव्स अँड स्टेशनरी वेव्स. ठीक आहे. बर, टेस्ट उद्या ना तुमची. जेई वाल्यांची पण आहे, नीट वाल्यांची पण आहे. जेई वाल्यांची कुठली? कुठली? WP. नीट वाल्यांची कुठली? थर्मल प्रॉपर्टीज. ठीक आहे, अभ्यास करा त्याचा. सगळं सॉल्विंग परत एकदा करा, बघूया काय काय मार्क येतात. ठीक आहे, लिव्ह केलं तरी चालेल.